Bien. Buenas tardes. Vamos a pasar ahora.
Right, good afternoon. Now we're going to explain to you the technology tested within the framework of soil cultivation, soil farming. Maybe the main problem when working in soil is that there is a kind of a black box from which we can draw no information. And considering the lack of data, farmers just have got their experience to draw from. And that means that people would over-fertilize in order not to fall short in terms of having an influence in the yield. Because we do not know the nutrient input provided by the soil, and also we do not know what's going up into the plant. If we add on to over-fertilization and excess water, there's the lixiviation, the leachate with high content in nitrates, pollution, but also it's a financial issue because there are overhead costs which amount to about 50% in terms of excess fertilization. Even if soil-less farming is important in greenhouse farming, most of the fertigated crops are planted in soil, so you need to have technology which will let us improve the use of water. And it is so important that it was the main task within the demonstration of the Fertinoa package, where a bigger number of partners took part. In fact, there were 8 partner members. 5 of them are in Spain, and 1 in southern France, CAPS in Slovenia, and PCG in Belgium. Most of us come from the Mediterranean region, about 6, plus 1 from Central and Eastern Europe, and another 1 from the Northeast. In terms of crops, there's a great variety. There are orchards, fruit trees. We may highlight cases drawn from tomato plantations and some very important financially important crops, for example, citrus fruits, olive trees, and apples. And it is the 3 partners, the 3 of us, working in greenhouses, the 2 ones from Almeria and the other 1 from France. The rest were coming from outdoor farms. Then with soil, also with sand mulching or plastic mulching. If we look into the technologies tested, starting by myself, we worked together with the Cajamar Foundation and the University of Almeria. There was no point in doing a similar work in the same area. We shared common interests and we focused more on the irrigation side, and they focus on the efficiency, the use of nitrogen. In terms of irrigation, our main objective was to show that there's a possibility to use simple technology, accessible technology, which can be controlled, which can help us control irrigation, so it can be adjusted to requirements of production. We used 1 selector tensiometers. The selector can be placed in the manometer wherever we want, and these tensiometers are linked to a small programmer that we use in the reception of the reference signals and issuing an outgoing signal when one or two of the sensors are active. This way, irrigation is automatically started. Also, we have done fortnightly sampling in order to measure electric conductivity and adjust the duration of irrigation so a good level of security was maintained. And around such a simple system, a reduction in the use of water was reached of up to more than 40%. The University of Almería focused on the improvement of the efficiency of nitrogen, and for that we have used a prescriptive corrective strategy which is based on the decision-making system linked to BEXIS, which contributes to the planning of fertirrigation, and that plan was adjusted based on corrective measures. In fact, measurements on the concentration of nitrogen were done both in the ground with suction pumps, also into the sap of the petioles, and both measurements were done very fast. In this case, the Aqua Twin without the need to dilute the sample, something which is quite important to do in the field. Also, April tested very many different technologies in greenhouses, both in terms of monitoring the humidity, the moisture content in the ground, also in nutritional terms. Existing technologies are available, but they are not yet. They are they're making a slow entry into farmers' fields. For example, devices for measuring nitrogen in the ground, also through colorimetric testing, and from then on they tested techniques such as the analysis of sap in the lab by sending samples to a Dutch lab, and through the use of sensors for measuring optical parameters. The INTIA had an interest in showing, in testing the decision-making system they have, an advanced system which is adjusted and takes into account the peculiarities of the plot in terms of the type of soil, etc. And they assess that with hydrological potential of the plant with the pressure chambers, and that meant the setting up of an exchange with IFITEC, because they have a long-standing experience in the use of reference values for this kind of testing. CAPT in Slovenia did something similar in terms of testing the local model they were already using, also in terms of adjusting irrigation to the forecasts, and also taking into account the hydrological balance in the ground. And they do forecasts with weather data, and also they use TDR probes in order to control the accuracy of the measurement. In the case of Belgium, PSG, outdoor irrigation, it is not generalized there, but because of fear of the climate change, they have been testing different kinds of irrigation methods, comparing unirrigated controls with plants with drippers, hose pipes, and in a especially dry year, the differences with regards to control plot were spectacular.
Valencia, bueno, tenía una especial...
Well, this work from Valencia, which we found very interesting because of the improvement of the management of irrigation in terms of farmers' communities. There's a big number of fruit plots which are first irrigated. They take into account model predictions, but also the peculiarities of the plot are taken into account. So they used capacitance sensors, so they could see the humidity profile, the depth of the humidity profile. So that improved irrigation in sandy soils. They also controlled the lixiviation of nitrates. And in Extremadura, they dealt with a very important system when trying to optimize the management of fertilization in large plots with a strong variability. So it is very important to get to know such variability, so control points are chosen for a better management of the plant. Carlos Campillo will speak a little bit more about this technology, and they have been working in mass measurements of apparent soil conductivity, so maps could be drawn. They also use drone images